Welcome back, guys. Today we'll be doing January 2019 CSEC Mathematics Question 4. Let's get started. For Part A states, given the function h of x is equal to 2x plus 3 all over 5 minus x, determine the value of x for which the function is undefined. What do we mean by undefined? A function is said to be undefined at points outside of the domain. So we need the value of x. So when I substitute it, it will not work. So we need x. What is x? And it should be 0 in the denominator when I substitute it. So in other words, what value of x, when I substitute it into this function, I will get undefined. For some persons, I'm sure when you're doing some calculation on your calculator, you will get math error. So say for example, and you can do this activity now, if you enter 2 divided by 0, you'll get math error, along with 3 over 0. So 3 divided by 0, you'll also get math error. So division by 0, it's not possible. So what are we asking you? When is it that the denominator will give me 0? Because once I have 0 in the denominator, then it will be undefined. So our focus is on our denominator. So undefined, our focus is on the denominator. When is it that I substitute a value here? I am going to get 0. Because once you have 0 in the denominator, it's not possible to get a y value because you're trying to find the y value. That's not possible here because if I have 3 over 0 or 2 over 0, any number over 0, I am going to get math error. So let's look at the denominator. So you can look at it first, look at it, and you can look at it and say, okay, what's the value of x that when I substitute it here, I will get 0? Some students are able to look at it and say, oh, when I replace x to be 5, and let's do that just by looking, x equal 5, substituting. So h of 5 means x is 5, so I'll be substituting 5 into the function. So I have 2 times 5 plus 3 over 5 minus 5. So all I did was replace x to be 5 in the two positions and calculating 2 5s 10 plus 3, that's 13 over 0 because 5 minus 5 is 0. So having this, it tells me that it's undefined. It's not possible to work this out. But you can also, if you're not able to just look at it and see x is equal to 5, you can also do the following. Look at the denominator. So the denominator, we are going to equate 5 minus x to be equal to 0. Solving, so I carry the x over the equal sign. So I have 5 is equal to x, which is the same thing as x is equal to 5. And here we're getting the same value. So when x is 5, when I substitute x to be 5 here, I will be getting a 0 in the denominator, and that makes it undefined. Just to ensure you understand, if I have h of x, and this is just me creating a new example, equal 2 over 3 minus x. Our focus is on the denominator. When is it that I will get 0 in the denominator? So we can either look at it to say, okay, substitute the value here. When I replace it, it should give me 0. Or I equate the denominator to be equal to 0. So I equate it to be equal to 0 and solve for x. So carrying this over the equal sign, so x is equal to 3. But the example that we got, just to reinforce, so to ensure we understand what's happening here, it's asking us, but which value of x will I get undefined? And it will be x equal 5, because when I substitute 5 here, without even substituting into the numerator, when you substitute it into the denominator, 5 minus 5 is 0. And when you have 0 in the denominator, if you enter 3 over 0 or 2 over 0, we're getting math error. So the solution for this, the value of x, for which the function is undefined, is x is equal to 5. Now, the next question we have here is asking us to determine, so we're still doing the same question, determine an expression for the inverse. We're going to find the inverse for the following function. So the first thing I'm going to do is change the hx to y. So I will have y is equal to 2x plus 3 all over 5 minus x. The next step, we interchange. So we're going to change this letter y to x. And then the x that we have here, we're going to change to y. So I'm going to have 2y plus 3 over 5 minus y. So this is where we interchange. So the y becomes x and the x becomes y. That's what's happening here. Now, after doing this, we're going to put this over 1 and cross multiply. So multiply x times the 5 minus y and 1 times 2y plus 3. So x times 5 minus y, I'm going to have it here, x times 5 minus y, getting rid of the fraction, is equal to 1 times 2y plus 3. So we cross multiply right here. Now clearing the bracket, x times 5, that's 5x. Then x times minus y, that's minus xy. And 1 times the entire bracket, I will just have 2y plus 3. Now the next step is that we're going to put the variable y on the left hand side and anything else that doesn't have y on my right. So this 2y will be going on my left and 5x will be going to my right. So it means I'll have minus xy, so I'll rewrite it as minus xy. Carrying the 2y over, so it becomes negative 2y. There's a change in sign. Is equal to 3. Didn't carry the 3 over the equal sign, but we carry the 5x over the equal sign, so it becomes minus 5x. The next step, I'm going to put a bracket here and factor out y. So when we factor out y, it means it's no longer in these positions. So what do I have left? Is minus x minus 2 is equal to 3 minus 5x. Then we divide both sides by minus x minus 2. So divide by minus x minus 2. This cancels, so y is equal to 3 minus 5x all over minus x minus 2. And this represents the inverse. So the inverse function is equal to 3 minus 5x over minus x minus 2. And that's it. Now for this function, it will work for all values except for when x equal negative 2. So when x, so it works for all values except for when x is equal to negative 2. So this function works. And just to make you understand, why is it that I have x not equal to negative 2? When we have fractions, we have to be very careful. We have to always think, can all the values of x work? So let's focus on the denominator that I have here, minus x minus 2. Will all the x values work? That's the question. Will it work? So when I substitute negative 2 into this function, I will have 3 minus 5, and then I have minus 5, and then x is negative 2 over minus 2 minus 2. So minus 5 times minus 2, that's positive 10. So this is 3 plus 10. But in the denominator, so this is negative and negative, that's positive. So that's positive 2 minus 2. So we will have 13 over 0 because 2 minus 2 is 0. So in this case, this inverse function is not satisfied when x is equal to negative 2, because when I substitute negative 2, it is not possible, it's undefined, and it will not work at this point. So this expression works for all values of x except at x equal negative 2. So that's why I have x not equal to negative 2. It's just signifying to the examiner that you understand that it works for all x values except this one. It will not work. The graph below shows a straight line intersecting the x and the y axis. Now I'm going to increase the graph just for now. So it intersects at this point, and the next point is here. So I've increased the size of the graph just to show what's happening here. We do have coordinate. See, it intersected at the y-intercept. We are able to count out what's the y value here. We know once we cut the y-axis, x is 0. But what is y? So we go 1, 2, if this is 2, then this is 3, then this is 4. So that means here is 4. So what we have for the y-intercept, I'm just going to write int, is x is 0 and y is 4. What do we have for the x-intercept? So this is the x-intercept that we have here, and we can count 1, 2, 3, 4, 5. So for the x-intercept, because you got the x-axis, that's why we call it the x-intercept. For the x-intercept, what's happening here is that y is 0, but the point that is right here is 5. So here we can see x is 5 and y is 0. So now I'm going to reduce my size. So the x-intercept, cuts the x-axis, count all the squares. So this is 1 unit, 2 unit, 3 unit, 4 units, and this is 5 units. So x is 5 and y is always 0 on the x-axis. The y-intercept, 1 unit, 2 unit, 3 unit, 4 unit. So y is 4, but x is always 0 on the y-axis. Now we can find the gradient of the line. I'm going to label this as x1, y1, and this is x2, y2. Find the gradient of a line. The formula is y2 minus y1 over x2 minus x1. So that means y2 is 0. Remember, I label y2 as 0 and y1 is 4. So I have 0 minus 4. The x2 is 5 and x1 is 0. So that means my answer is negative 4 over 5. Because 0 minus 4 is a negative 4, and 5 minus 0, that's 5. So it's minus 4 over 5. Now we're asked to determine the equation of a line. So the equation of a line is y equal mx plus c. Now c represents the y-intercept, and we don't have to calculate what's the y-intercept because we were given this. Remember, I've already established that this is the y-intercept, and the y-intercept is x is 0 and y is 4. So that means c is equal to 4 because c represents y-intercept. So the y-intercept for this graph, c is equal to 4. Y-intercept means where does it cut at the axis? It cuts it at y equal 4. So c is 4 So C is equal to 4, and the gradient was already calculated on the previous slide. The gradient is negative 4 over 5. So just to replace what is M and what is C, I'll have y is equal to negative 4 over 5 x, and then my C plus 4. And that's it. This is the equation of the line. Now the next question is asking to determine the equation of the perpendicular line that passes through P. So the equation of the line that passes through P. Now, once it is perpendicular, the second gradient is M2 is equal to minus 1 over the first gradient. That's how we find the gradient of the perpendicular line. Now, M1 is minus 4 over 5. So replacing here, I'll have minus 1 over minus 4 over 5. The first thing is a negative number, so we cancel the negative. Negative divided by negative, that's positive. So we have 1 over positive 4 over 5. Whenever we have a fraction in the denominator, we can reciprocate it or flip it, so it becomes 5 over 4. So the fraction is being flipped. Now, if you're wondering how, 1 over 4 over 5 is the same thing as 1 divided by 4 over 5. So you have 1, change the division to multiplication, and then you flip it, so it becomes 5 over 4. And then 1 times 5 over 4 gives us what we have here. So that's how you get it. Now, the next thing is to find the equation of the line. So we're going to have y is equal to mx plus c. Since it says it passes through the point P, this point from before, it's 5, 0. So this is x and this is y, and I'm going to use these points. So y is 0, x is 5, and the gradient is 5 over 4 plus c. 5 5 is 25, so I have 0 is equal to 25 over 4 plus c. Then carrying this over the equal sign, so I have minus 25 over 4 is equal to c. So the equation of the line, y equal the gradient, which is 5 over 4, x minus 25 over 4. So what's happening here is that we replace the gradient, m is 5 over 4, and c, which is minus 25 over 4. And that's it. Thanks for watching. Don't forget to like and subscribe to my channel. Have a great day.